Hi and welcome again. Today we are talking about the runtime of hash sets. It is really likely that you get asked why the access time of a hash set is 1, for example, if it's constant, or why the search time in a hash set is constant. Well, the idea behind a hash set is that there are key value pairs stored similar to a hash map or a dictionary in Python. Well, the hash map is usually the prime example for Java, and in Python it is the dictionary where you can access it in a array-like manner. Well, the keys are usually then the hash of the actual element that you want to insert into the hash, and the values are the elements to be inserted into the set. Well, and the keys are stored in an array, and you can access this then with the hashed element as index. Well, and that gives you an access time that is constant into the hash set, because access times of arrays are seen to be constant. Well, how does that work exactly? Well, if we have an item 1 here, then we build the hash of the item 1, which is done usually in constant time. That is one condition on a hash function. So we have here the hash of item 1. So now imagine we also have item 2 that we do the same, also a hash function on this item 2. And interestingly, the hash function is unique for each item if they are not equal, or at least it is assumed to be. Otherwise we have a hash conflict, and these have to be treated in a special way. But for now we just assume that these hashes are unique for each item we put in if they are not equal. Alright, and now we have our two hashes, so we can use these as keys in the array. So now we have here our array. Let's start at the top where we have the index 0, for example. There is our hash of item 1, so the hash here is 0. And there at position 3 we have the hash of item 2, so the hash of item 2 has to be 3. Alright, and these are the keys then of our array. And then our values are the actual items that we want to store in our array. So here we have our item 1 on position 0 and our item 2 on position 3. Alright, so let's implement a little dummy of a hash set in Python. Well, for that I open my Visual Code here, and there I create a new file called hashset.python, and there I create a class and I call that hashset. Well, in there I want first the array where I want to store my items in, and I call this R here, and I say in the beginning that is none. And then we also need a size of our array. Let's say the size is none for now too, because otherwise we get into some trouble when we want to initialize our array, because I'm going to use numpy for that. So let's write our constructor here. So we say def init, and that has self property, and it gets a size as an argument. And initially I want to say here that the size is 10, so we don't have to give it necessarily, but we just put it in for now. And then we say our self.size equals size, because we will need that later. And then we say our self.array is a numpy array, and there we fill it, so we say full. And there we also have to import numpy first, so import numpy as np. I usually like the namespace np because that is kind of usual. And there we say that the shape equals to, and there we take our size, or let's use our class self.size, and we want to fill it with a fill value. So we have here fill value, and I want to use here none for now. So when we insert or when we create it, it is just full of nuns and it doesn't take too much space then. If we want to add an item now, then we go in and say def add. We want to add an item to our hash set. So we say here that we add, and we give it the property of self, and we give it an argument of value. And then we can say here add an item to the hash set. And then we go in and check now. Or other, we can actually say self array. And there we want to use our hash. And therefore we have to find out our index, which is in the end our hash. Since we are limited to a certain size of the array, we have to get into the range of our array, and I will use the modulo operation there. So we say here, we say hash, which is the Python hash method, and there we say value modulo, and there we use self.size. So we will always be in the size of our array. And let me actually use here the size. I want to make that private, so it can't be changed after we created the class, or at least can't be changed from the outside. There have to be a different method where we can change the size of the hash set, but this is usually done by concatenating and recalculating the hashes. Alright, so here we say self.array is equal to our index, or the index of our array, and there we store our value now. Alright, and that should be it so far. Usually this computation here, this is much more complicated and there is a lot of logic going into it. But for now we keep it nice and simple because we just want to have a basic hash set. Then we go in and create a print method, and there we simply say print self.array, where we just print our array that we have. Alright, let's try that out. We say if name equals to main. So basically we enter our main class, our main method in Python, and there we create an instance of our hash set, and I say my set equals to hash set, and I just want to leave it like that now. And then I say my set dot add, and let's just add a few numbers here. I say 1, 2, 3, 2, 3, and here maybe the 1, 2, 3, 1 like this. And then we print our set, and then I say here my set dot print, and we just see how it looks now. Alright, so what is the output here? We have here our hash set with the nonce. We see that our hash function actually worked fine, and we have on index 1 the 1, on index 2 the 2, on index 3 the 3, on index 5 we have this number. Alright, so and there we can also have a look at the hash collision, for example, because we have a kind of small set here. If I do add and then put in the 30, let's say 30, that should work. Then as you can see now, Okay, that works. So let's say my set.add. Let's use the 40. And as you can see now, before we had here the 30 at the index 0, and now we have the 40 at index 0. And that basically means that we have a hash collision here through our index computation. If we would make it a lot bigger here, our hash set, let's say we use here 100 if that works already. So 100 elements can be stored in our hash set. Then we should see all our numbers here. 1, here's a 30. And if we go further up, we have the 1, 2, 3. And I'm still looking for the 40, but that should be here somewhere. Here it is. Alright, and there we don't have a hash collision anymore. So we should also consider initializing the set big enough that there are no collisions. Yeah, and that is basically a hash set in a nutshell. We have our transformation of indices and hash values so that we can store the elements in an array. And with that we get really good access and search time and so on. Alright, ladies and gentlemen, that's it for this video. Thanks for watching. Yeah, if you liked it, give it a thumbs up. Tell me down in the comments below what you think about this video. And subscribe to the channel if you like to get informed whenever I'm uploading new videos. Have a great day. Bye.